All right, so here's another example of finding volumes by slicing a three-dimensional figure. And so in this case, we've got a pyramid that looks like it's 2 meters by 2 meters on the base. And so it's a square pyramid, and the height is 2 meters. All right. And so if we take cross sections, if we slice it horizontally now, then you can see all of those cross sections are just squares, and we can easily find the area of a square. And then if we take it times the thickness, we get the volume of each little slab. And so, so one thing I want to do here, in order to find the volume of any given slab, what I need is an equation for the side of each square, right? And it's going to vary as you go up, right? So what I'm going to do, I'm going to draw a little picture of what this, this triangle looks like. So we have, let's see, we're going up by 2 and over by 1 in either direction. So I'm just going to draw this on a Cartesian coordinate plane, right? So that's sort of what the cross section, if I divide it vertically, that's what the cross section looks like. But that'll help give me the equation for, how the width is changing, the width of each square is changing as I go higher and higher in the pyramid. All right, so this is 1, this is -1, and this is 2. So this is my y-axis, this is my x-axis. All right, now if we had the equation of this line, right, if we can find the equation of this line, I can't draw a straight line, but if I have the equation of that line, then I know that that's halfway across the square, right? Because essentially if I were to draw what this, I could draw what this pyramid looked like. It's sitting on a base, right? And it has this triangular shape going up. All right. And then so the width of this at any given point is the width of each square. All right, so let's try and find an equation for this line. Now I know the y-intercept is 2, so all I need is the slope. So, and it looks like I'm going down by 2 and over by 1, so that tells me that I have a slope of -2. So it's -2x plus 2 will be the equation of that line. Okay, so, so this is x and this is x, so the width is actually in terms of x. So I'm going to rearrange this, and so that I have x, right? And so I can, and actually I can just, if I just add 2x to both sides and then subtract y, I'll get 2x is equal to 2 minus y. Okay, and actually what I want is 2x, right? Because the width, if I go over x in the positive direction and x in the negative direction, then my width of any given square is going to be 2x. So I'll just leave it that way. 2x is equal to 2 minus y. Okay, so that's the width of any given slab, these square slabs, right? So let's figure this out. So we're going to find the volume of any of a slab. Call it a slab or a slice or however you want to term it. And we know that each slab is a square, right? Is a square prism, I guess you could call it a square. Okay, so I can find the cross-sectional area just by taking length times width, which is just this going to be, since it's a square, I'm just going to take, essentially 2x squared times delta y, but 2x I know because I want to integrate with respect to y, so 2x is equal to 2 minus y, quantity squared, delta y. Okay, so that gives us the volume of any little slice, any little slab. And then we just want to add up all those little volumes. And we want to go all the way from the base at 0 to 2 meters up. And we're going to just add up the volumes, right? So this is 2 minus y squared times, now it's this delta y becomes dy when we take the limit as n goes to infinity. All right, well, this will be easier, I think, if I just expand the square. So let's do that. So if I square this out, 2 squared is 4. First times last times 2 gives me minus 4y. And then the last term squared becomes plus y squared dy. All right, we can easily integrate that. So the integral of 4 becomes 4y. The integral of minus 4y becomes minus 2y. And the integral of y squared becomes 1/3 y cubed. And we want to evaluate that from 0 to 2. All right, so let's plug in 2. Now you can see when we plug in 0, everything becomes 0. So all we really need to do is plug in 2. So we're going to have 8. Oops, this should be 2y squared, shouldn't it? 8, and then we're going to 2 times 2 squared, which is 4, which becomes 8. So we have 8 minus 8, so that just becomes 0. And so then we have plus 1/3 times 8. All right. Well, so that's just 8/3. 8/3, and the units are in meters, so the volume is meters cubed. And that's all there is to it. Just adding up those little squares, just like we did the Riemann sums.